Hello everybody, welcome into another lesson. So today we are going to continue on with our inverse matrices. We're going to take the inverse of a 3 by 3 matrix. And again, in order for a matrix to have an inverse, two things must be true. One, it's got to be a square matrix, meaning it has the same number of rows as it does columns, such as a 2 by 2, a 3 by 3, a 4 by 4, what have you. And then the other condition is the determinant has to be 0. Otherwise, it's what's called not invertible, which means it doesn't have an inverse. But here you have matrix A, which has various letters here to represent various coefficients, or constants rather, that you may have. The first thing you want to do is take that original matrix, set up what's called a double augmented matrix. And to the right of that augmentation, you'll have the identity matrix, which is, this is the 3 by 3 identity matrix. You can do this with a 2 by 2 system, but you're doing a lot more work than you need to. That's why we taught the shortcut method for the 2 by 2. But for a 3 by 3, you really have no choice. Or for higher than that even, you have no choice. But the idea is to get the inverse matrix, you'll do some elementary row operations to get the left side into reduced row echelon form, which will yield the identity matrix on the left and then some different values on the right side of the augmentation. The right side of that augmentation, once you've gotten your left side into reduced row echelon form, that right side becomes your inverse matrix. And still, to check if you so choose, you can take your original matrix A times your inverse of A matrix, multiply them, and you should get the identity matrix for 3 by 3. So I have about 3 examples here. It is going to be rather lengthy, I'm not going to lie to you. It will be rather lengthy, but let's go ahead and get started here. So why don't we say, matrix A has entries of -3, 4, 5, 1, 5, 0, 5, 2, 2. You have your original matrix. Right away, don't waste any time, go ahead and convert this into a double augmented matrix with the identity matrix on the right. Okay, so we've done that now. First thing I'm going to suggest is we switch rows 1 and 2, because that'll enable the leading digit in row 1 to be a 1. So that's kind of the idea. Let's switch rows 1 and 2 around. Nothing too crazy just yet. So if we switch rows 1 and 2 around, row 2 becomes row 1, you'll get 1, 5, 0. But that means everything to the right of the double augmented line also switches places. So it'll become 0, 1, 0. Then you still have your 2 other rows. Well, let's see. Your row 1 becomes row 2. So that'll be -3, 4, 5. And then you'll have 1, 0, 0 for here, and then row 3 we just left alone for now. 5, 2, 2, 0, 0, and 1. Okay, so there's rows 1 and 2 switched around. Now the next thing we want to do is get the first digit in rows 2 and 3 to become 0. So if I take 3 times row 1, add that to row 2, and then if I take -5 times row 1 and add that to row 3, I can make it happen in each row. So let's go ahead and do that here. So it's determined that we're going to leave row 1 alone for now, which would be 1, 5, 0, Then to the right of the augmentation, 0, 1, 0. Alright, so let's deal with rows 1 and 2. So 3 times 1 is 3, minus 3 is 0. Alright, then 3 times 5 is 15 plus 4 is 19. 3 times 0 is 0 plus 5 is still 5. Alright, then 3 times 0 is 0 plus 1 is 1. 3 times 1 is 3 plus 0, that's 3. 3 times 0 is 0 plus 0 is still 0. Okay? Now let's deal with rows 1 and 3. Negative 5 times 1 is negative 5 plus 5, also 0. Alright, negative 5 times 5 is negative 25, plus 2 is negative 23. And then negative 5 times 0 is 0, plus 2 is 2. Alright, negative 5 times 0 is 0, plus 0 is still 0. Negative 5 times 1 is negative 5 plus 0, that's negative 5. And then negative 5 times 0 is 0 plus 1 is 1. So there's your new second and third rows to start with. Now, the very next thing I'm actually going to suggest is that we make the second digit in row 3 also a 0. So if I take 23 times row 2 and add that to 19 times row 3, I should be able to make that happen. So yes, we're about to have a nightmare on our hands. So row 1 is still left alone. We'll have 1, 5, 0. Then the augmentation of still 0, 1, 0. Alright. So let's see, row 2 itself we're leaving alone just for a minute here. Alright, so first entry still 0. That hasn't changed. But what about the second entry? Well, 23 times 19 minus... Sorry, yeah, 19 times 23 minus 23 times 19, that's 0. Okay. 23 times 5 is 115 plus 19 times 2 is 38. So we need to figure out 115 plus 38. That would give you 153. Awful. It's just awful. Alright. Now, 23 times 1 plus 0 is 23. 23 times 3 is 69 minus 19 times 5, which is 95. So we got to figure out 69 minus 95. That'd be negative 26. Alright, and then 23 times 0 is 0, plus 19 times 1, that'd be 19. Okay, next thing you probably would want to do is first you want to make sure that leading digit in row 3 is a 1. So you simply should take row 3 and multiply it by a scale factor of 1 153rd. So let's do that. 1 over 153 times row 3 will yield a brand new row 3 where the leading digit's a 1. So if we do that, row 1's still left alone for now. Row 2 we're still leaving alone just for now. Row 3, so you still have 0 and 0 for the first two entries. 1 over 153 times 153 is 1. So now we have a leading 1 in the third row. But 1 over 153 times 23 they're not divisible by each other, so you'll just end up getting 23 over 153. All right. 1 over 153 times negative 26 would give you negative 26 over 153. And then 1 over 153 times 19, also not divisible by each other, would give you 19 over 153. Awful. It's just awful. Now, the next thing we probably should do is make the third digit in row 2 a 0. If I take negative 5 times row 3 and add it to row 2, I should be able to make that happen. So negative 5 times row 3 plus row 2. Let's go ahead and make all that happen here. So row 1, still leave it alone for now. All right. So let's see. First entry in the second row will still be 0. Second entry in the second row would still end up being 19. All right. Negative 5 times 1 is going to be negative 5 plus 5 is 0. So negative 5 times 23 1/53 is negative 115 53. We got to add that to 1. So that'd be 153 minus 115. That's going to give you 38 153. Now, negative 26 times negative 5 would turn into, should be positive 130 over 153. Then we got to add, oh boy, so what's 3 times 153? So that's 459 plus 130. That would give you 589 over 153. And then negative 5 times 19 153 is negative 95 153 plus 0. That gives you negative 95 over 153. And then row 3 we can leave alone. Row 3 is finally reduced enough. Let's make this a little bit bigger, shall we? It does get awful. All right, now we got zeros where we want them so far, but the leading digit in the second row needs to be a 1. Well, we have a positive 19, so we need to take 1/19 of row 2. Let's go ahead and do that here. Another awful one. So row 1, just leave it alone for a minute here. Alright, so 1/19 of row 2, that's still 0 for the first entry. 1/19 of 19 turns into 1. 1/19 of 0 is still 0. Now, 1/19 of 38 1/53, that would become 2 153. And then let's see. Does 19 go into 589 at all? I'm just very curious. It does 31 times. So you'll end up getting 31 153rds. And then 1/19 of negative 95 153rds, that would be negative 5 153rds. And then we're leaving row 3 alone because it's already reduced. So row 3, you have 0, 0, 1. And then you have, wow, 23 153rds, negative 26 153rds, and then 19 153rds. All right, now the last thing we need to do to get this into reduced row echelon form on the left is make that second digit in row 1 a 0. Well, if we take negative 5 times row 2 and add to row 1, we can make that happen. So negative 5 times row 2 plus row 1 will indeed achieve that. So let's see. If, of course, the first entry is still going to be 1, that hasn't changed. Negative 5 plus 5 is 0. Third entry is still a 0. Now this is where it gets interesting. Negative 5 times 2 153rds is negative 10 153rds plus 0, so you'll end up getting negative 10 153rds. All right, now 31 153rds times negative 5, that's going to be negative 155 53rds plus 153 33rds. That would be negative 2 153rds. And then negative 5 153rds times negative 5, that would be 25 153rds plus 0. That would give you 25 153rds. So yeah, these are just downright awful. There's no lie about it. And then your other rows, they're already reduced. So let's see, 2 153rds. 31 153rds, then negative 5 153rds, and then we have the last row, 0, 0, 1, would give you 23 153rds, negative 26 153rds, and then 19 153rds. So now that we have the left side of the augmentation in reduced row echelon form, which is the identity matrix, the right side is our inverse matrix. So let me just erase one of these here so I can, or maybe more, so I can show you what the inverse matrix looks like. So A inverse would be equal to this awful, hideous thing of negative 10 153rds, negative 2 153rds, and then 25 153rds. That's just your first row. Let's erase some of that so I don't run out of room, huh? Because we have a lot of fractions here. Second row was 2 153rds, 31 153rds, negative 5 153rds. Last row has 23 153rds. Then we have negative 26 153rds. Then we have 19 153rds. So there's this lovely piece that is the A inverse matrix. And if you took A times your A inverse, you would in fact get the identity matrix. So that's quite awful, isn't it? Now, a lot of people opt to find the inverse of this by using a graphing calculator, but I still have to teach you how to do it by hand. So let's go ahead and do the next example here. Alright, so let's see. A is a matrix with entries -7, 0, -6, and then -4, 1, 3, 11, -3, and -9. Well, you have your original matrix. Why don't we just go ahead and put this into augmented form, the double augmented form? So your identity matrix will go on the right. You don't have a leading 1 anywhere in this, unfortunately. You just don't. So the goal's still the same. Make the first digit of the second and third row become 0. Well, to deal with the second row, if I take -4 times row 1 and add that to 7 times row 2, I can make it happen there. Then, if I take 11 times row 1 and add that to 7 times row 3, I can make it happen there. So, let's go ahead and set up this wonderful new matrix. So, alright, -4 times -7 is 28, plus 7 times -4 is -28. Whoops, hold on a minute. I didn't do this right yet. I need to keep my first row the same. I'm jumping ahead of myself here. It'd be nice to be that far, but wishful thinking, right? Alright, but anyway, so if you take -4 times -7, that's positive 28, minus 4 times 7, that'd be minus 28, so you have a 0 for your first entry in the second row. So -4 times 0 is 0, so just plus 7 times 1, that'll be 7. Now, if I take -4 times -6, that's positive 24, plus 7 times 3 is positive 21. That's going to be 45. And then, alright, if I take -4 times 1, that's -4 plus 7 times 0. That's just going to give me -4 on the right. -4 times 0 is 0, just plus 7 times 1, that'll be 7. And then you have 0 for the last entry here. Alright, now let's deal with rows 1 and 3. So 11 times -7 is -77, plus 7 times 11 is positive 77, so you'll actually end up getting 0 here also. Alright, 11 times 0 is 0, minus 7 times 3, that'd be -21. And then, let's see, 11 times negative 6 is going to be negative 66, plus 7 times negative 9, that's negative 66 minus 63. So let's solve that. I get negative 129. Okay, so 11 times 1 is 11, plus 7 times 0, I'll just get 11 here. 11 times 0, 0, then you still have a 0 here. 11 times 0 is 0, plus 7 times 1, so that's 7. Alright. So we've made the first two entries of rows 2 and 3 be 0. The next thing I'm going to suggest is we make the second entry of row 3 also be a 0. We have an easier way out this time. If we just multiply the second row by 3 and add it to row 3, we can do that. So take 3 times row 2, add that to row 3, and you'll make that happen. So let's go ahead, come over here and do that. I know I'm all over the place and I apologize, but anyway, first row we're leaving alone for right now. Same with the second row. We're not quite changing it yet. We will change it, but we're not ready to do that just yet. Alright, so let's see. 3 times 0 is 0, plus 0 is still 0. 3 times 7 is 21, minus 21 is also 0. 3 times 45, let's figure that out. That would give me 135 minus 129, that just gives me 6. Now all of a sudden that's really not too bad to work with. Not at all. That's not bad to work with at all. As a matter of fact, it's actually going to save us a little grief here. I'll explain in a minute. But now if I take 3 times negative 4, that's negative 12 plus 11. That becomes negative 1. If I take 3 times 7, that's 21 plus 0, that becomes 21. And 3 times 0 is 0 plus 7, that's just still 7. Okay. We can do a couple things here. Next thing I'm going to suggest actually is we go ahead, we make the third entry of both rows 2 and 1 become 0. So let's start with row 1. Well, I can just simply add row 3 to row 1 and get rid of that negative 6. So add row 3 to row 1, we'll take care of it there. And then if I take negative 9 times row 3 and add it to row 2, I can make it happen there. Alright, so row 3 plus row 1, 0 plus negative 7, still negative 7. That hasn't changed. 0 plus 0, still 0. Now, 6 minus 6 is 0. That just changed. Alright, negative 1 plus 1 is 0. 21 plus 0 is 21. 7 plus 0 is 7. Alright. Now let's deal with rows 3 and 2. So, negative 9 times 0 is 0, plus 0 is still 0. Negative 9 times 0 is 0, plus 7 is still 7. And then negative 9 times 6. Oh my gosh, I did that wrong. No, I see what I did, guys. I'm sorry. 6 and 45 are not equal. That means the 6 does not break down into 45. But, I'm not too far off the path. I'll tell you how. Forgive me for that error, folks. I would have really fouled this up. Okay. Well, we can still deal with rows 3 and 1 quite easily. Just add row 3 to row 1. But what about rows 2 and 3? Well, 6 and 45 actually both go into 90. If I take negative 15 times row 3 and add that to 2 times row 2, then I can make that happen. So please forgive my error there. Yes, I still make mistakes, but anyway, row 3, 0 plus negative 7 is negative 7. I'm glad I caught it now than it getting published. 0 plus 0 is 0. 6 minus 6 is 0. Negative 1 plus 1 is 0. 21 plus 0 is 21. 7 plus 0 is 0. 7 plus 0 is 7. What the heck am I saying? Good Lord. It's Friday, right? Okay. Now, let's see here. Deal with rows 3 and 2. Negative 15 times 0 is 0, then you just have a 0. So you still have a 0 there. Negative 15 times 0 is 0, plus 2 times 7, that would just give you 14. Alright. Negative 15 times 6 is negative 90, plus 2 times 45 is positive 90. That would give you a 0 there. Alright, negative 15 times negative 1 is positive 15, plus 2 times negative 4. 15 minus 8 is 7. Wow, this is going to be huge. Yes, sirree. Deal with this 21 and negative 15. So 21 times negative 15, that's negative 315, plus 2 times 7 is going to be 14. So you should end up getting negative 301. And then negative 15 times 7 is going to be negative 105, plus 2 times 0. You just get negative 105. And then row 3, you still have 0, 0, and 6. And then everything to the right there. Okay. Well, good news is, for each of these 3 rows, we have zeros in every place we need. The problem is the leading digit isn't 1, but that's an easy fix. We can manipulate all 3 rows easily. If we take negative 1/7 of row 1, you'll end up getting that leading digit to be a 1. If you take 1/14 of row 2, you'll get the leading digit to be a 1. And if you take 1/6 of row 3, you'll get the leading digit to be a 1. So that's actually a fairly straightforward fix. So negative 1/7 of row 1, so negative 1/7 of negative 7 is positive 1. Of course, you multiply it by 0, you'll still get 0. Now, still by 0, you get 0. Negative 1/7 of 21 is negative 3. Negative 1/7 of 7 is negative 1. Alright, first row didn't go too bad. Now the second row we got to take 1/14 of, which 1/14 of 0 is still 0. 1/14 of 14 is 1. 1/14 of 0 is also 0. 1/14 of 7 is positive 1/2. 1/14 of negative 301. I know it's not going to go into it evenly, but what I wondered is, does 301 divide by 7? It does, 43 times. So you would end up getting negative 43 over 2. And then, of course, 1/14 of negative 105, that divides by 7. That'll give you a negative 15 over 2. Alright, so we got our row 2. Now let's figure out what the row 3 is going to be. So 1/6 of 0 is 0. Again, 1/6 of 0 is 0. 1/6 of 6 is going to be 1. Alright, so 1/6 of negative 1 would be negative 1/6. 1/6 of 21, both divide by 3, you would get 7/2. And then 1/6 of 7 would just give you 7/6. So on the left side now you have the identity matrix in reduced row echelon form, so everything to the right of the double augmented line is your inverse matrix. So A inverse is equal to 0, negative 3, negative 1, 1/2, negative 43 halves, negative 15 halves, negative 1/6, 7 halves, and then we have 7/6. So there is your A inverse, this awful thing right here, which it's really not that awful. I feel like this one went a lot better than the last example we did, but there is your inverse matrix. I got one more, then we're done. We will be done after this next example here. Okay. A has the entries, let's see, 2, 1, negative 2, 5, 3, 0, and then 4, 3, and 8. Alright, let's not waste any time. Let's go ahead and get this matrix double augmented. So set up the identity matrix on the right. Alright, so you don't have a leading 1, but that's okay. First thing you want to do, get the first two digits in the, get the first digit in both the second and the third row to become 0. If I take negative 5 times row 1 and add that to 2 times row 2, I can make that happen there. So negative 5 times row 1 plus 2 times row 2 will make it happen in the second row. And then if I just take negative 2 times row 1 and add that to row 3, I can make it happen there. So let's go ahead and set this up. Row 1 we're still leaving alone for now, the 2, 1, and negative 2. 1, 0, 0, okay. Now, negative 5 times 2 is negative 10, plus 2 times 5 is positive 10. That'll give you a 0. Alright, negative 5 times 1 is negative 5, plus 2 times 3 is 6. Negative 5 plus 6 is positive 1. Alright, now, negative 5 times negative 2 is positive 10, plus 2 times 0, you just get positive 10. And then, let's see, negative 5 times 1 is negative 5, then you have a 0, so here's a negative 5. Negative 5 times 0 is 0, plus 2 times 1, that's just 2. Negative 5 times 0 is 0, plus a 0 is just a 0. Alright, now let's deal with rows 1 and 3. Negative 2 times 2 is negative 4, plus 4 is also 0. And then we have negative 2 times 1 is negative 2 plus 3 is, well, 1. That's very nice, actually. You'll see why in a minute. Now, if I take negative 2 times negative 2, that's actually positive 4, plus 8 is 12. Now take negative 2 times 1, that's negative 2 plus 0 is negative 2. And then negative 2 times 0 is 0, plus 0 is also 0. Negative 2 times 0 is 0, plus 1 is 1. Alright. How nice is this? This is actually quite nice, because I have a leading 1 now in the second row, and both of the first digits in each row are 0. My next goal is going to be to make the second digit in the third row become a 0. Well, if I just negate row 2 and add that to row 3, I can easily make that happen. That'll take like next to no effort at all. So, let's see here. Row 1 we agreed to leave alone just for a minute. Alright, now row 2, we're still leaving row 2 alone just for the time being. Alright, negative of 0 is 0, plus 0 is still 0. Negative 1 plus 1 is 0. Negative 10 plus 12 is 2. And then, let's see. What we have next is going to be negative 5 is positive 5, minus 2 is 3. Negative 2 plus 0 is negative 2. Negative 0 plus 1 is still 1. So there's your new row 3. Now, what I'm going to suggest we do next is make the third entry in both rows 2 and 1 become 0. So let's deal with rows 1 and 3. Well, that's by inspection. If we just add row 3 to row 1, we can make that last entry become a 0 in row 1. So row 3 plus row 1, that's easy. Now, if I take negative 5 times row 3 and add it to row 2, I can make it happen in row 2. So negative 5 times row 3 plus row 2, I'll make that happen. So let's see, rows 3 to 1, well, 0 plus 2 is still 2. 0 plus 1 is still 1. Now, 2 minus 2 is 0. Alright, let's see, 3 plus 1 is 4. Negative 2 plus 0 is negative 2. 1 plus 0 is 1. Alright. And then let's see, now we're dealing between rows 3 and 2. 0 plus 0 is still 0. 0 plus 1 is still 1. Negative 5 times 2 is negative 10, plus 10 is 0. And then we have, let's see here, we have negative 5 times 3 is negative 15, minus 5 is negative 20. And then we have negative 5 times negative 2 is positive 10, plus 2 is 12. And then we have negative 5 times 1 is negative 5, plus 0, that's negative 5. Well, we finally reduced the second row. Row 2 is not a far cry off. Row 3 is not far. We'll deal with that in a minute. First thing I would do before you reduce row 3 is I would make sure that second digit in row 1 also becomes a 0. Well, easy enough. If I just negate row 2 and add it to row 1, I can make that happen. That'll easily happen if I can just do that. So let's see, negative of 0 is still 0, plus 2 is 2. Negative 1 plus 1 is 0. Negative 0 plus 0 is still 0. Alright, negative 20 actually ends up being positive 20, plus 4 is 24. And then negative 12 minus 2 is negative 14. Negative 5 is positive 5, plus 1 is 6. And then we just have rows 2, which are being left alone. Negative 5. Then we still have row 3. Alright, it's almost in reduced row echelon form, but not quite yet. I need the leading coefficient in each of the rows to be a 1. I'm already there with row 2, but in rows 1 and 3, my leading digit's a 2, which means I just simply need to take half of each of those rows. So if I take 1/2 of row 1, and then also 1/2 of row 3, I'll get there. I can just leave row 2 alone because it's already there. That'll give me then 1, 0, 0. Half of 24 is 12. Half of negative 14 is negative 7. Half of 6 is 3. Alright, row 2 is already there. We can leave that alone. Now row 3, half of row 3, you'll have 0, 0, and this time 1. Half of 3, unfortunately, we're just stuck with 3 halves. Half of negative 2 is negative 1. Half of 1 is, well, 1/2. Only 2 fractions out of this. That's actually not terrible. Now, you have here on the left side the identity matrix in reduced row echelon form, which means everything to the right of the augmented line is your inverse matrix. So let me erase this so I can write it in its proper form. So the inverse matrix, which is a to the negative 1, the inverse of a is going to be the matrix of 12, negative 7, 3, negative 20, 12, negative 5, 3 halves, negative 1, and 1/2. There is your inverse matrix of A. Would be 12, negative 7, 3, negative 20, 12, negative 5, 3 halves, negative 1, and 1/2. And if you multiplied A times A inverse, you should get the identity matrix. So that's it for this lesson. We got 2 more lessons left in matrices, then we're going on to quadratic functions. I'm sure some people are relieved that we're about done with matrices, but both of those lessons will be using inverse matrices to solve a system of equations, which, full disclosure, that's not a method I would pick if you have many options to choose from. That's actually probably the last method I would pick, but I still have to teach it because that is a viable method to solve a system of equations. So I do hope everyone has a great night. Take care.